What it's going to do is it's going to continue to take a 3D scan. Each scan only captures what's facing the scanner. And so it's going to continue to rotate it and take a scan. And when it's done, you can fuse all those individual views to create one 3D object. Image and 3D data exploitation and analysis. So we do a number of projects involving understanding images and 3D geometry. You can see it captures the pedestal, the clay that I use to hold the bone up, and the actual bone here. You can see it with the colors. This is a skunk's skull. Here you have the sort of the eye sockets. Every time it takes a scan, I get more points. So what looks like a solid 3D surface here is in fact a whole bunch of points. So this is a 3D face scanner that doesn't use a laser. Instead, what it's going to do is it's going to take pictures from multiple points of view. With 2 points of view, you can judge what's the disparity between the two images. The projector is going to project a pattern onto his face. Since his complexion isn't that bad, there aren't a lot of visual cues to judge the disparity between points on his face. So this is going to put a pattern on his face that allows it to capture a bunch of points.
I like to think of social embeddedness as technical embeddedness, and the user-inspired research translates to the applied research we do in this lab. So most of our projects are funded by, say, United States Army, National Science Foundation, and other entities who want some products developed in software that can be useful for other applications.
And we have a project, for instance, with the Army, where we're digitizing a bunch of faces and trying to, recognize what's what, align them with a database of faces so we can understand the distribution of shapes, and then even estimate missing shapes like the internal anatomy or repairing holes.